Okay, 2.3 factored form of quadratic function. We are going to factor and find zeros in order to graph. So we've found the vertex and then just another point. We've had the vertex form and we've graphed that way. Now this is another method that you can use when it is in standard form. It won't always work because your x-intercepts aren't always nice. It doesn't always have x-intercepts. If I take a quadratic function and I move it over here and it goes up, is it going to have x-intercepts? No. So this method that we're doing isn't always going to work. But if it came over here, would it work? Mm-hmm. Yes. So what we're learning are different ways to do it. So when you get an option, you can do what's appropriate or easiest or what you like, depending on how you want to look at it. So factor x squared plus 7x plus 12 on your own, please. So you should get x plus 3 and x plus 4.
Yep.
Okay? So 2x minus 5 minus 3. Leave yourself a little bit of room under A because we're going to do something else with it.
Oh, you want us to do B now?
Mm-hmm. But leave yourself some room under A. We're going to do something with it in a second.
Oh, wait.
Where do you get 6?
Yeah, where'd you get negative 6?
Factors of 6 that subtract a 5.
You have
No,
to, you have
the
to
on
times
top.
the 3 by the 2.
The 3 by 2.
Why don't you do 5 by 2?
Because up here is A times C. And down here is B.
Oh, okay.
Okay, that makes more sense. I wrote it like weird though.
Okay. So, did you get 2x plus 1, x minus 3?
Mm-hmm.
Okay, so what we just did are actually the first step to finding the zeros. So all we do now is set the whole thing equal to 0. So that means both factors. And you look at them individually. So I have 0 equals x plus 3. What's x equal? 0 equals x plus 3. What's x equal?
0.
0. Negative
X.
Negative 3.
Y.
Could you take it over?
You subtract it over.
Yeah, I just got really confused.
Well, that was a complete guess, to be honest.
No, it's basic
Like,
algebra.
Like say
Yes,
trying to
you're
say-
solving.
say you're
X
trying to get
equals.
X by yourself. How do you get X by
I want
yourself?
x
You're trying to
equals.
figure that out.
So what's this one? X equals what?
Negative 4.
Negative 4. If I was writing on my own, I would write negative 4, negative 3. So I now know
I don't know how to leave this one.
Okay, so I have my zeros when y is 0, x is -3 and -4. Okay, do we know, does it open up or down?
It'd be up,
It'd be up,
'cause there's
Right.
negative, yeah.
so it would be up. And we also should know that the vertex would be exactly in between that, yes?
Yeah.
So it'd be -3.5, so that would be -7.5. Okay. Do we also have h equals -b over 2a? Yes.
Yeah,
So b is,
7.
so -7 over 2.
2. Yeah.
Isn't that -3/2?
Yep.
Yeah.
Yes.
That's,
If I needed the y value, then I would plug it in here and find it. Yes?
Yeah.
But can I just sketch right now?
Uh-huh.
Okay. Now you will have to be exact with your vertices sometimes, and sometimes you won't.
How did you find it though?
it's just a sketch.
It's just
so
a
the
sketch.
-7 over 2 is where the vertex is.
Yep. That's what we did
So it'd be
last week. Okay, so the next one, set it equal to what? 0. And solve for x. So x equals what?
1/2.
-1/2.
I was getting there.
You have to subtract the 1.
Yeah.
Subtract the 1, divide by 2,
Then
X
3.
equals 3.
and 3. What's my h?
Negative, no. Yeah. 5 over 2.
5 over
4.
4. So 5/4 is another nice one, right? Ha ha ha.
Why'd you get rid of the negative?
Because it's negative. The formula is -b.
Oh.
Okay, so -1/2 and 3. Open up or down?
That'd be up.
Up.
Up. And the vertex is 5/4, so 1 1/4.
Oh.
So somewhere like here, right? Can I calculate it if I want to?
Sure.
Oh, I also know the y-intercept's what? Easy. What's the y-intercept?
Yeah.
-3.
Yeah,
So are there things that I can figure out?
Yeah.
What's the y-intercept over here?
12.
12.
I was gonna ask
So
that.
that's clear up, right?
Mhm.
So we're not, if it's not going to, if I cross it, I need to mark it. If I don't cross it, I don't need to mark it. Yes,
How do you know if it's opened up or opened down?
A.
So is it like the A, B, C? And A
It is the ABC.
So
Okay, so factor.
those are what I got confused on, but I think I figured it out on the homework.
Oh, I don't like
Does
that.
x plus something and x minus something?
Yes.
Yes, what is it?
X plus 3.
X plus 3, X minus 3, Y. Is perfect squares.
Shut up, guys. You actually had help doing this. No.
Dylan figured it out without help.
Ooh,
I
good
was
job,
doing
Dawn.
this.
And I helped you last year with it. Does it open up or down?
Up.
Up. What's the y-intercept?
Negative 9.
-9.
Negative.
I said negative.
I was just telling you not to close it.
I know.
And that also is my what? Is it also my vertex?
Mm-hmm.
Because 0 is exactly between -3 and 3.
Yeah.
So would there be like a, isn't this like a minimum, maximum, all that stupid stuff?
We can. Yep.
No.
I'm just saying, I'm not implying.
Yes,
that
I
one.
could ask you for
No.
everything.
No, you could.
Yes. Okay, factor 3x squared minus 7x plus 2. Dylan, are you okay?
Oh, I have a question.
Spacing.
So on example B, when you were finding it, you
Mhm.
had like 2x parenthesis x minus 3. How did you get 2x plus 1 out of that? Like, I obviously know you have to multiply them, but like, how do you get 2x times negative 3? How do you get 1?
Are you meaning this?
It was minus 3.
Oh, well, whatever.
But yeah,
So,
how do you get 1 of that first?
because what's right here?
One.
A 1.
Yeah, but that doesn't help.
There's always a 1 in front of the parentheses.
There's always at least a 1 in front of the parentheses.
That's not what I'm asking.
What are you asking?
Like, the 2x parenthesis x minus 3, how did you get 2x plus 1 out of that? Like,
I didn't. I got 2x plus 1 out of this and that.
Yeah. That's where the plus 1 comes from.
Alright.
Okay, so do you guys get 3x minus 1 and x minus 2?
Yeah. Did you do that in your head?
Yeah.
That's stupid.
No, I still do. I do 6, negative 7, and I know it's negative 6 and negative 1, but then remember how I said this is factors of A
Yeah.
and this is factors of C?
Mhm.
Well, the only 2 factors of 3 I have are 3 and 1. That's it.
Yeah.
So the only factors I have here are 1 and 2. So in order, and remember how I said this multiplication and this multiplication gives you B?
Yeah.
So the only way I can get 6 is 2 times 3.
Mhm.
So that's where it has to go. So I'm multiplying while I'm dividing, basically. So I didn't do it in my head, but I followed the pattern, I guess.
You didn't show your work.
Okay. No, and actually when I was taught to factor, we did not do the X method.
Did you get that?
We did not. Like we did this, like we did this over here,
Mhm.
but we never made an X. We never put it back into factoring by grouping. We just had to do it. He actually had us list factors. We would do this, and you'd go 1 and 3, 1 and 2, and you had to figure out where to place them. So if you know that this times this and this times that gives you B, it makes it much quicker. Now, this works great when that first one's prime. 1, 2, 5, 7, all those work really great. So, what?
I'm confused with my work and I don't know what I'm doing wrong.
What are your zeros? X equals?
1/3 and 2.
Okay, so X equals 1/3 and 2. So then I would, does it open up or down?
Oh,
Up. Y-intercept is
2.
2. So 1/3, I don't know there. 2.
Mhm. Ew. You know what?
okay. I have a question. Why didn't you solve for H on this one?
I can. What's H?
I have 7/6, but I don't know how to plot it on the graph.
Right. 7/6 would be 1 and 1/6. So it'd be like, you, and then 1 and 1/6 would be your X, so you'd have to plug it back in here to get your Y. And I don't think you want to plug in 7/6.
So I just kind of guess.
Yeah, it has to be halfway in the middle. Where mine's at, it's actually probably pretty close. You just don't know how far down it goes.
Okay.
On good ones, you need to do it. What do you mean by good ones?
Or they don't get a fraction.
Yeah.
Yes, ones that don't get fractions. Or easy fractions. Like everything's divisible by 2 and you get a half or something. Okay, so in this graph, it shows a function defined as y equals x squared plus 2x minus 8. How do the zeros of the function relate to the factors of the expression? Well, the zeros of the function should be the zeros of the factors, yes?
Yeah.
Okay, so what are the factors of negative 8 that have a difference of 2?
4 and 2.
4 and 2. So x plus 4 and x minus 2.
Yeah.
And then you set them equal to,
0.
and I get -4 and 2. I kind of already told you the secret.
Light work.
No reaction.
Guys, factoring doesn't ever go away. So you got to be able to do it whatever way you do it, proficiently and accurately. Because if you factor wrong, you're probably going to mess up like everything else. When we get into graphing rationals this year, you start this year, you work more on it next year, and you finish it up in calculus. And pre-calc has already done it this year. Calculus is starting it right now, and you guys will be starting it soon. If you mess up factoring, which is the first step, calculus is an entire page of work. If you mess up the first step, what's that going to do for everything else?
Wrong.
It's going to be wrong. So factoring is truly one of the most important things you do in math because it doesn't ever go away. And don't we always want to know when something hits 0, breaks even? Think about money. Do we always want to know like when we cut even on money? Yeah?
Yeah.
That'd be a 0. Or when we have no money, that would be a 0. So those are really important in math and things. Okay, so let's factor this one. I have x squared minus 9x plus 20.
5 and 4.
5 and 4, so x,
Wait. Oh, yeah.
I don't think it's, yes, it is 5 and 4.
X
And they're
minus
both
minus
negative, yes? So what are my zeros? X equals,
5, x equals 4.
so 4 and 5. And so the vertex has to be exactly in the middle of that, right?
Yeah.
So it'd be 4.5. The vertex is always exactly between the two vertices. Unless it is the vertice. Could it be the vertice? Yeah? Because the parent function, doesn't the parent function look like this? Ooh, that's horrible. Doesn't it look like that?
Yeah.
Well, that's the x-intercept, and that's the vertice. So can it be the same? Yep. Okay, zero product property states that if the product of real numbers factor is 0, then at least one of the factors must be 0. I.e., if A times B equals 0, or either A or B is 0. So when I'm saying A's and B's, what am I talking about? A x squared plus B x plus C.
It'd be finding A would no Y. I said a letter. I don't know.
Okay. To use the zero product property, rewrite the equation so that is equal to 0 and factor. It's what we've just done, guys. When you solve in a quadratic equation, every single time it has to be set equal to 0. You have to set it equal to 0. Before you factor. Now, there are other things you can do besides factoring to solve, but before you factor, you have to have it equal to 0. Before you do the quadratic formula, which you're going to do soon, it has to be set equal to 0. It just is it. Okay? So, solve the quadratic equation by factoring. So, what do I have to do first? Just wrote it in huge, big letters.
I think you
Set it equal. Okay, how?
Put zeros on it. Girl, slap them.
How do I set that equal to 0? It's equal to 42 right now.
You have to get it back over where there's no equal sign and then
Right,
And
so
subtract it.
subtract it. So I subtract over 42. So x squared plus x minus 42 equals 0. Then factor. So factor it.
Aw.
Hopefully you got 6 and 7.
I was thinking about it, I looked up.
What?
I was thinking about it.
Oh, thinking about it. Okay, why did I not go through all the steps with this one and the other ones I did? Some of them I did. What's different about this one? What's different about this one, A and B, on this one? Like,
X, there's not, it's 1.
well, A is 1 here, yes. A is
Two.
not 1 there, is it? So can I just do that
Yeah.
when it's 1, right? Okay, so what's X equal on here?
-7 and +6.
-7 and 6. Now, don't tell me this is big mistakes people say. They're like, ooh, it's positive up here. They're like +7, -6, and guess where they write it?
Pause.
Are those the answers? Nope, those are the factors. So the factors and answers are two different things because you have to set the factors equal to what? 0 and solve. So 2x squared equals -x plus 5.
So 10 and 1.
What's wrong with what Carson just tried to do?
No,
Because
I'm
10 and 1.
10 minus 1.
You're gonna,
-10 and +1.
you're gonna set it to 0.
You have to set it equal to 0. Okay, are you going to move it left or right?
I don't know.
Right.
I'm going to move it left. My choice. Why would I move it? Why would you move it left, Jenna?
You mean
They'd be moving
because you just said left,
No, I said left or right.
and I just said
Oh, you said right.
Right.
Why would you move it right?
I don't know because I just said something because I don't understand.
Okay. Anybody else? Left or right?
You're only right because you're only moving one number.
Okay, so if I move it right, I'm only moving one number, but what's that do to my A value?
Makes it negative.
Makes it negative. And before I factor a negative A, I have to factor out a negative, right? So I just added an extra step. Do I want to add an extra step?
No.
Not in that, right? So do you see why I want to move everything left?
No.
Yeah.
If you move it right, I don't have a problem, but you're going to need to factor out a negative.
You're
Okay.
gonna forget it.
Now, I will tell you sometimes I do move it right if I see them like they're all divisible by that first number, but I'm not factoring out just a negative. So I get x squared, what?
Plus 9x minus 5.
And thank you for remembering
Equals 0.
to change the sign on both. Yes, and equal to 0.
Yeah.
So factor it.
Yeah.
-10. It's 10 and it's 1 and 10.
Okay, so do your work to get 1 and 10.
1 and 10.
Is it not?
It is.
Yeah. See?
Oh, I was,
Well, it's positive 10, negative 1.
Where are you writing?
This,
The answer?
that's what I got.
That's not what you got. You need to get that.
I do have that.
Because you wrote down mine or because you
No.
knew?
Because I had to change the 10 into 10.
Because this right here, I have to get
Negative.
10 and negative 1, right?
10, yeah.
See how that works? Because the factors of 2 are what? 2 and
Okay.
1. And in order to get 10, this has to be a 5. Is 5 a factor of 5? Yes. And I will keep doing them like that. You guys can do the method, the X, if you want. Do it right. Okay? I'm not going to do it. You know it. So you do it and I'll do it. And we better get the same thing.
Wait, can you do that one more time?
What?
The-
Like how I did it?
Please report to class.
Okay. So I, in my head, I did the negative 10, 9.
Mm.
Okay, so then I know it has to be 10 and negative 1.
How's
So-
the negative?
What? It's -10.
Because
That's
it's
minus 1.
negative 10, so it has to be subtraction.
How's the negative 10?
Because it's a negative
2
5 times
negative
2.
5 times negative, 2 times negative 5 is negative 10. Okay, so then I go this.
I was looking at the wrong one.
Okay, I know the factors of A go here. And the only factors, I wrote an A instead of an X. The only factors of 2 are what? 2 and 1. It's the only factors. Don't have a choice. I need 10. So 2 times
5.
5, and 5 is the only factor of 5, and I need positive 10, so this is a positive, so this better be a
Negative. No
Positive.
positive. And the only other factor of 5 is 1, and I need it to be a
Negative.
negative. So that's how I did it.
Okay.
Okay, so what does x equal?
Negative 5.
Negative 5 and
1/2.
and could I graph it from there if I was asked to? Opens up or down?
Up.
Up. Okay, I have the 2. What's the y-intercept?
5.
No,
No. Negative.
negative 5. Why can't I use this one up here?
Because you changed it.
It's not set equal to 0, right?
Mm-hmm.
And if you had it negative 2x squared plus, nope, minus 9x, it would all be weird. Then it would open a different way and
Yeah, and it'd be wrong.
it would twist your brain. Okay, solve the quadratic. You got 2. Let me see what I have. No, I've seen what we have for examples. Okay. It goes on to the graphing, which you've done. And then application, but the application is just why we need to know the zeros. The biggest thing, what do you think you guys are going to forget to do?
Set it to 0.
Mm-hmm.
Nope. Not this guy.
Carson will never forget again. What?
Does it matter what order they're in?
Like the quantity? No. The numbers in the quantity, yes.
Oh, would you do both of them?
No,
Yes.
she just said we did.
I don't mean this sarcasm.
It wasn't so bad.
I don't think that was-
Okay, he hits it off the second, which is 32 feet high. The height of the ball, x seconds after Marco hits it, is modeled by the function.
Can you
So-
divide by something first?
What?
Can you divide, make them smaller?
Yes, we will do that.
Please.
What you have there is actually a position function that's used in physics a lot. Once you get into pre-calc and calc, you'll write your own equations. But let's talk about it. 32 feet high. Where's that in my equation?
The
The
C.
The C.
yeah.
Because that's your y value, isn't it?
Yeah.
You're going to hit the ball, and it's going to do what?
That's his
Go
height.
up and then come back
Yeah.
down. This negative 16 is actually gravity. The force of gravity.
It was gravity.
No, say the whole thing again.
16
It's
is
out.
gravity.
Negative 16 is the force of gravity because it's negative because it's bringing it what?
Yeah.
Down. Okay? And then 16 is the velocity. But that's besides the point. So when does the ball hit the ground? Well, the ball hits the ground at what?
6. On the X.
32.
I'm starting at 32. I hit the ball. Where's the ball hit it?
0.
0. When x is 0, yes?
Yeah.
Or when y is 0, sorry. When y is 0, we got to find that x. I want to know how long, because it says when, and it says X seconds, so X are seconds, right?
Uh-huh.
How long that ball is going to be in the air before it touches the ground. Okay? So, Carson said, what did you want to do?
Make them smaller.
Can I make them smaller?
Divide by 16.
I can divide by, and I'm going to make it a negative 16. Why negative 16?
Because the
Then
first,
it can't.
Get rid of that negative, right?
but then it changes everything.
Yep, it does. But you're better off having a positive A value than a negative A value. I'm going to tell you right now, in my 19 years of teaching, I've had one student that could accurately every single time factor with a negative in there. And she astonished me because I can't do it right every single time. I mess it up because I forget about it. I can do it, but it's like too hard on my brain. Okay, so x squared minus x minus 2.
Plus, oh yeah, minus. Oops.
Oh, well, now this equals what? 0. Because that's going to be the height when it hits the ground, right? So that should be easy. What and what?
1 and 1.
No.
Negative
No.
2, negative 1.
Negative
Negative 2,
2 and
1.
1.
2 and 1.
Negative 2 plus 1.
I was getting there.
Okay, now we also have this negative 16 out here, yes?
Yeah.
And I have to set every single thing to 0.
Yep.
So what do I get here with these two?
The x.
What do I get? X equals what?
Oh, negative 1
Negative.
and.
No, 2, negative 1.
Well,
No,
negative 1 and
negative
2. It doesn't matter. I always write them least to greatest, but it doesn't matter. Okay, but we have the 16, and I'm supposed to set it equal to 0. Can 16 equal 0 without a variable?
No.
No. So it doesn't equal, does it?
No.
So is it a solution?
No.
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 What if it was 0 equals 16x?
Yeah.
Then the answer would be 0, right? But without that x there, that isn't like it's a false statement. So it's not a 0.
Try to figure out when the ball hits the ground.
Yep. So these are seconds, yes?
Yep.
How about negative 1 seconds?
No.
Can I have negative 1 seconds?
Nope.
No. So when does it, after what?
2
After 2 what?
seconds.
Seconds. Now, this is a time where this parabola, guys, does not have a domain of all real numbers.
It could keep going.
Nope, that's not the problem.
No.
What's the problem?
It stops.
Does this exist
No.
over here? No. So it's not all real numbers. What is it? Domain x such that x is greater than equal to what?
0.
0. Because I don't care about anything before 0 time, do I? No.
Already happened. Can't change it.
Okay. So remember I said quadratics are always all real numbers except in application problems. Be on the lookout for them to say, and what is the domain on an application problem? Okay. Now, what's the range? Let's talk about that one.
That'd be. Oh.
Okay, here's the ground, yes?
Yep.
And this was 32? So I would need to know what this value was right here. How could I find that value? Carson, put your chair down, please. Where's the range come from when you guys wrote the range? Where'd you get what?
The 1.
The y, the k of the vertex, yes?
Yeah.
So do I have to find the vertex? Okay, so the h would be negative b
Over 2a.
over 2a. So 32.
Yep.
So it'd be negative 1/2. Okay, so negative 1/2.
Yeah.
Oh, no. Negative, it'd be positive. Why can't it be negative 1/2? Because
It'll
the
go back
arc
down.
comes out in front of them, right? Okay, I forgot the negative 16 was, so it's 1/2. So I'd plug 1/2 into this equation. Would you like to plug it into this equation or this equation?
That one.
Top or bottom?
Bottom.
Bottom. Why?
Small number.
Smaller numbers. Okay. I wanted to put in the top one. You know why?
Why?
Because what is 1/2 squared?
I don't know.
1/4. Does 4 go into 16?
Yeah.
Does 2 go into 16?
Yeah.
Yeah. So if I put it into this, the second one, I'd have to get common denominators and add them and all that before I multiplied by 16.
Okay, so the top one.
So the top one. So 1/4 of negative 16 is
4.
negative 4. Okay. 1/2 of 16, 8. And then plus 32.
Mm-hmm.
So 40 minus 4 is
38.
36.
I miscalculated. I added 4.
Okay. So this up here is 36. When do I stop caring what the ball does? At the what?
0.
At the 0, at ground level, right?
Mm-hmm.
So my y such that 0, because it always starts at the bottom, right? It's going to be less than equal to the y and less than equal to the
36.
36. So when I put this in an application problem, does it take me a little bit more time to figure out the domain and range? Yes. Okay. The next one is the same exact example, basically. Identify positive and negative intervals. We will do that tomorrow. Factor, please listen. On these problems, factor it just like you would and graph it. Okay, factor and graph it. And then we'll talk about what the positive and negative intervals are tomorrow. And it will make more sense when you have your graph in front of you. Okay, so when you get to identify intervals, positive and negative, just factor and graph it, and then we'll finish it tomorrow.
Okay.